For any assignment-related queries, call us at +1 678 648 4277. Visit https://www.statisticsassignmenthelp.com or email support@statisticsassignmenthelp.com. 1. Which among the following techniques can be used to aid decision-making when those decisions depend upon some available data? A. Descriptive statistics. B. Inferential statistics. C. Predictive analytics. D. Prescriptive analytics. Sol. A, B, C, D. The techniques listed above allow us to visualize and understand data, infer properties of datasets and compare datasets, as well as build models of the processes generating the data in order to make predictions about unseen data. In different scenarios, each of these processes can be used to help in decision-making. 2. In a popular classification algorithm, it is assumed that the entire input space can be divided into axis-parallel rectangles, with each such rectangle being assigned a class label. This assumption is an example of A. Language bias. B. Search bias. Sol. A. The mentioned constraints have to do with what forms the classification models can take rather than the search process to find the specific model given some data. Hence, the above assumption is an example of language bias. 3. Suppose we trained a supervised learning algorithm on some training data and observed that the resultant model gave no error on the training data. Which among the following conclusions can you draw in this scenario? A. The learned model has overfit the data. B. It is possible that the learned model will generalize well to unseen data. C. It is possible that the learned model will not generalize well to unseen data. D. The learned model will definitely perform well on unseen data. E. The learned model will definitely not perform well on unseen data. Sol. B. C. Consider the rare situation where the given data is absolutely pristine, and our choice of algorithm and parameter selection allow us to come up with a model which exactly matches the process generating the data. In such a situation, we can expect 100% accuracy on the training data as well as good performance on unseen data. Where we create some synthetic data having a linear relationship between the inputs and the output and then apply linear regression to model the data. The more plausible situation is of course that we used a very complex model which ended up overfitting the training data. As we have seen, such models may achieve high accuracy on the training data but generally perform poorly on unseen examples. 4. You are faced with a 5-class classification problem, with one class being the class of interest, i.e., you care more about correctly classifying data points belonging to that one class than the others. You are given a data set to use as training data. You analyze the data and observe the following properties. Which among these properties do you think are unfavorable from the point of view of applying general machine learning techniques? A. All data points come from the same distribution. B. There is class imbalance with much more data points belonging to the class of interest than the other classes. C. The given data set has some missing values. D. Each data point in the data set is independent of the other data points. Sol. C. Option A is favorable, since it is an implicit assumption we make when we try applying supervised learning techniques. Option B indicates class imbalance, which is usually an issue when it comes to classification. However, note that the imbalance is in favor of the class of interest. This means that there are a large number of examples for the class which we are interested in, which should allow us to model this class well. Option C is of course unfavorable as it would require us to handle missing data, and given the extent of the data that is missing, could severely affect the performance of any classifier we come up with. Finally, option D is favorable since, once again, it is an assumption about the data that we implicitly make. 5. You are given the following 4 training instances. x1 equals -1, y1 equals 0.0319, x2 equals 0, y2 equals 0.8692, x3 equals 1, y3 equals 1.9566, x4 equals 2, y equals 3.0343. Modeling this data using the ordinary least squares regression form of y equals f x equals b0 plus b1 x, which of the following parameters, b0, b1, would you use to best model this data? A 1 1, B 1 2, C 2 1. Let us consider the model with parameters 1 1. We can find the sum of squared errors using this parameter setting as Sol A 0 minus 0.319, 2 plus 1 minus 0.8692, 2 plus 2 minus 1.9566, 2 plus 3 minus 3.0343, 2 equals 0.12. Repeating the same calculation for the other 3 options, we find that the minimum squared error is obtained when the parameters are 1 1. Thus, this is the most suitable parameter setting for modeling the given data. 6. You are given the following 5 training instances. x1 equals 1, y1 equals 3.4, x2 equals 1.5, y2 equals 4.7, x3 equals 2, y3 equals 6.15, x4 equals 2.25, y4 equals 6.4. x5 equals 4, y5 equals 10.9. Using the derivation results for the parameters in ordinary least squares, calculate the values of b0 and b1. Note that in the expression for b1, the last term in the denominator is a, b0 equals 7.54, b1 equals 0.57. b0 equals 2.484, b1 equals 0.969, c, b0 equals 0.969, b1 equals 2.484, d, b0 equals 1, b1 equals 2.5. Sol C. According to the derivations we saw in the lectures, we have and. Using the supplied data, we have n equals 5. Using the above calculations, we have. Using this value of b1, we have 7. Recall the regression output obtained when using Microsoft Excel. In the third table, there are columns for t-stat and p-value. Is the probability value shown here for a one-sided test or a two-sided test? A. One-sided test. B. Two-sided test. Sol B. Recall that the null hypothesis used here is h0, bi equals 0, where bi is the coefficient corresponding to the ith variable, I greater than 0, and b0 is the intercept. 8. In building a linear regression model for a particular dataset, you observe the coefficient of one of the features having a relatively high negative value. This suggests that A. This feature has a strong effect on the model, should be retained. B. This feature does not have a strong effect on the model, should be ignored. C. It is not possible to comment on the importance of this feature without additional information. Sol C. A high magnitude suggests that the feature is important. However, it may be the case that another feature is highly correlated with this feature and its coefficient also has a high magnitude with the opposite sign, in effect cancelling out the effect of the former. Thus, we cannot really remark on the importance of a feature just because its coefficient has a relatively large magnitude. 9. Assuming that for a specific problem, both linear regression and regression using the KNN approach give same levels of performance, which technique would you prefer if response time, i.e., the time taken to make a prediction given an input data point, is a major consideration? A. Linear